So while we've been working on the force practice problems, I've gotten this question a lot. What is weight? A lot of times when we think about weight, we're thinking about how much we weigh, and we're thinking in terms of pounds. So one thing I want to get straight right off the bat is this idea. Get rid of that. When you're talking about your body weight, fine. Talk about pounds. But in terms of science, we're not looking at pounds. We are going to be talking about newtons when we're talking about weight, and we're going to be talking about kilograms when we're talking about mass. So weight, we're going to talk about newtons. Mass, we're going to talk in kilograms. Your weight, if we think about when what we're talking about when we're saying okay, I weigh 300 pounds, that means that your mass is being pulled on by gravity with a force of 300 pounds. Now again, we're going to start using newtons. So what we're talking about here is really force due to gravity, or as you've probably seen me write it, F of G, force due to gravity. Mass, that's the amount of matter that you are made of. Matter you're made of. So this does not change. Does not change. At least when you move from planet to planet. Obviously, as you grow bigger, or let's say you go on a diet, then fine, the amount of mass, the amount of matter that you are made of can go down. But when we're talking about whether you're on the moon, or whether you're on Mars, or whether you're on Earth, your mass will be the same. However, your weight will change because each of those planets have a different gravitational pull. So if we're looking at a problem and we're looking for the weight, F due to G, force due to gravity, is equal to mass. I'm going to put that in a box because that is the object. The mass of the object is never going to change. That block that's sitting on the table will always be that block, whether it's on Mars or whether it's on Earth. So mass times acceleration due to gravity. We know that on Earth, that number is going to be 10 meters per second squared. On Mars, that number is going to be 4 meters per second squared. And on the moon, that number is going to be 1.6 meters per second squared. Now, I don't expect you to know Mars and the moon. Those I would always give you on any kind of practice problems or homework or test. But Earth, this is the number that we should definitely know. So if a problem is ever asking you about the weight of a spaceship, there was a practice problem that we did where it said, sorry, I'm trying to get this to move down. The weight of the spaceship weighs 9,800 newtons. So with 9,800 newtons, that's not its mass, that's its force due to gravity. So we would set that up just like a force problem. It is a force problem. 9,800 newtons is equal to whatever its mass is times acceleration due to gravity. In this case, since we're talking about on Earth, we're talking about 10. So here, it's really simple. We can just divide both sides by 10, and we will be left with mass equaling 980 kilograms. So that tells us the mass of that spaceship. If we want to know how much it weighs on the moon, right, what its weight is, what the force due to gravity on the moon, we would just multiply it by 1.6. If we want to know about how much it would weigh on Mars, we multiply it by 4. If we wanted to know about how much it would weigh on, Jupiter or the Sun, which are much heavier planets, they're much more massive. The sun's not a planet, but they're much more massive. It would be greater than 10 rather than smaller than 10 because they'd have a stronger gravitational pull, and therefore objects would accelerate at a greater rate. So here's the mass. If you want to find out how much it weighs on a different planet, which might be a problem on a quiz or test or practice problem, you just multiply it by the acceleration due to gravity, or A of G, on that specific planet. I will give you what that number is every single time, unless it's Earth. On Earth, I expect you to know it's 10. Hope this was helpful. Thank you.